Let us look at proposition number 9 of book 9 of Euclid's Elements. The proposition says, if as many numbers as we please from a unit are in continued proportion and the number after the unit is square, then all the rest are also squares. And if the number after the unit is a cube, then all the rest are also cube. Let's see how we can prove this. Now, we are given unit A, B, C, D, E in continued proportion. And A is a square because A is the number after the unit. In this illustration, the unit is not shown. A, so which means A is second number, B is third number, and so on. We know, we have seen previously in the previous position, the third number, that is the number B, unit A, B. So third number B from the unit is a square. And not only that, number starting from B, that is the third number, and skipping 1 is also a square. That means what? From B is the third number, unit A, B. Starting from there, every alternate number is going to be a square because A is square. So which means B, skip C, D, skip E, F. So B, D, F are squares. We have already proved this. Okay, now the only thing we have to take care of is the remaining. Now, which are the remainings? C and E. So let's take ABC. Now, since this entire thing is in continuous proportion, that means ABC is also in continuous proportion. So, and we know that if three numbers are in continued proportion and the first one is a square, then the third one is also a square. So since A is square, C is also square. Next, we take BCD. Since the entire thing is in continued proportion, that means BCD is also in continued proportion. And again, three numbers in continued proportion. If the first one is square, then the third one is also square. So which means since B is square, D is also square. Now you got the idea, I think. Take the next three numbers. C, D, E are in continued proportion. Now, since C is square, that means E is also square. And depending on the numbers that we have been given, or in other words, number of numbers that we have been given in continued proportion, we can keep doing this and we will find that all the terms are square if A is a square. Now, the proposition doesn't stop there. It says that if A is cube, then the rest are also cubes. So let's start. A is a cube. We know unit is to A is equal to A is to B. Unit is to A as A is to B. Now we know C is a cube. Again, previous proposition, we have seen this. C is a cube and all others skipping two numbers are also cube. So that means 1, 2, 3, 4. Fourth number is a cube and then skipping two numbers, the number we get will also be a cube. That means C and F are cubes. Now we have to prove the remaining number. Now unit measures A the same number of times as A measures B. Unit measures A the same number of times that A measures B. But unit measures A based on the units in A. In modern terminology, this is nothing but A is equal to A times unit. In our case, it will be 1. So A measures B based on the units in A. That means what? B is equal to A times A, which means A is a cube. We have started with that. That means B is also a cube. Now think about this. A is a cube. We multiply it with another cube. We get the result as a cube. Again, we have proved this previous. Now we start off. We start with 4 numbers. A, B, C, D are in continued proportion, and we know given 4 numbers in continued proportion, if the first one is a cube, then the fourth one is also a cube. So since A is a cube, D is also a cube. Now we take BCDE, that is also in continued proportion, and B is a cube. We saw this here. So which means the fourth number will also be a cube. So E is also a cube. So A is a cube, B is a cube, then D is also a cube, E is also a cube, and here C is a cube, and all other skipping two numbers are also cubes. So which means F is also a cube. So we have shown that given a continued proportion starting from a unit, if the second number is a square, then all the rest are squares. And if the second number in the continued proportion from unit is a cube, then all the rest are also cubes. So that is proposition number 9 of book 9 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.